Professor Zawala again. Today we're going to go over the first in a series of 2 videos on number bases. Number bases is a subsection of the number and numeration section of the West African examination, senior secondary school certificate examination, mathematics for Liberian schools. In this video, we're going to be going over how we can convert from one base to another. Basically, we're going to be converting from, say, base 10 to another number base, and from, say, a number base, a binary base, to base 10, or between bases. So first of all, let's go over some basic introduction to number bases. The number system we use is a base 10 number system. So that's why when we count, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Once we reach 9, we have a 1, 0, which we come to call 10. And then we'll go 1, 1, which we call 11, and so on. When a number is written without a subscript, the number is assumed to be a base 10 numeral. When a number is written with a subscript, that number is the base to which that subscript is. As you can see over here, we have 2 different numbers here. One is in base 2 and one is in base 5. It's also normal to hear people refer to base 2 as a binary number system, as well as base 16 as a hexadecimal number system, and base 8 as an octal system. First thing we're going to be going over is converting from any number base to base 10. There's a little procedure, an algorithm that you can follow. You start, say, from the right, start with the digit at extreme right and begin to multiply by the powers of the digit. All right, we're going to show you how it works. And the reason for that is, like, when we are using the base 10 number system, if I write 2, 3, 6, so basically 2, 3, 6, 2 is in 100 position. It's the same as 2 times 10 squared, because it's in 100 position. And then 6 is in the 10th position, so it's the same as 6 times 10. And 1 is in the 1's position, so it's the same as 1 times 10 to the 0 power. 10 to the 0 power is 1. So we're going to go ahead and do the first problem here, which we have to do here is to, okay, then we also have, say, how do we convert from base 10 to any number base? We use division. We divide and put the remainder on the side and put the quotient under it, and then we divide again by that particular base until we reach a point wherein the dividend is, the quotient is 0. And then we can write the result by starting from the last of the remainder moving to the first. So let's go ahead and do some problems and see how we work on that. So the first problem we have here is problem number 1. This is a problem that we're not seeing on the West African Examination Council, but it's a concept that is it's in the curriculum, but we haven't been able to see, we're not able to find any problem that in past exams on the WAEC. So it's a creation of field. There are other methods for doing this. I'm just going to show you one in the many different methods you can do to this problem. So we're dealing with base 7. So we're going to divide this by 7. So how many times will 7 go into 86? Basically, 7 will go into 86 12 times. And I will show you how it works. And then if I do 7, 12 times 7, 7 times 2 is 14, 7 times 1 is 7 plus 1 is 84. So I'll have 86 minus 84, that's going to be remainder 2. It went in 12 times, I put 12 here, and then I'm going to put the remainder of, the remainder was what? 2. So I put the remainder of 2 over here, and now I'm going to divide this dividend, this quotient here again by what? 7. When I divide 12 by 7, 12 divided by 7 will be 1, and it will be a remainder of 5, because 7 times 1 is 7, 12 minus 7 is going to be 5. I put that remainder over here, and then again I must continue to do it until I have a quotient of 0. Now 7 goes into 1, it's not possible, so we say 0 times 7 times 0 is 0, 1 minus 0 is 1. So we have it, we stop here because we have reached a 0. So 86 base 10 is equivalent to we must read our result from the bottom up. So it's equivalent to 1, 5, 2 base 7. Okay? And you can always go back and check it up and see how we landed on that result. So this is how we will change from base 10 to a number base. Now, we're going to see how we can move now to another one to see how we can proceed to the next video, which is number 2. So here we have the numeral 2201 in base 4, and we want to change this to base 10. This problem was taken from the WAEC 2011. It was problem number 4018. We're going to write out this numeral 2201 base 4, and each of these numbers moving from the right to the left is going to be, our base here is 4 raised to the, so it'll be the product of this number and the base raised to the 0 power, and then we're going to increase the base by 1. 4 to the first power, 4 to the second power, 4 to the third power. This is basically the same way our number system works. So let's see how we do it. Then we're going to find this product, 2 times 4 to the third power plus 2 times 4 to the second power plus 0 times 4 to the first power plus 1 times 4 to the 0 power. So what is 4 cubed? 4 cubed is 4 times 4 times 4, which is 16. Sorry, 64. So we have 2 times 64 plus 2 times 4 squared is 16 plus 4 to the first power is 1. So we have 0 times 4. I'm just going to do orderly. Plus 1 times anything raised to the 0 power is we agreed is 1. 2 times 64 is 128. Plus 2 times 16 is 32. 0 times 4 is 0. 1 times 1 is 1. So we're going to add these numbers here. 128 plus 1 plus 32 is 160 plus 1. That's going to give us 161 base 10. So 2201 base 4 is basically 161 base 10. The approach here is that they want us to change, basically, this problem is taken from WAEC again 2012. It was problem number 5. So basically, you've been given 145 base 6, and they want you to convert this to base 4. So the way we're going to engage this problem is to change from base 6 to base 10, and then convert from base 10 to base 4. So let's see how we do it over here. So let's change this again. So again, we're going to write this number as 1, 4, 5. And since we are dealing with base 6, we're going to begin here by saying 6 to the 0 power and increase by adding the powers, increasing the powers by 1. So basically, in converting this to base 10, it will be the sum of the product of the digit multiplied by the powers given over here. So that will be 1 times 6 squared plus 4 times 6 to the first power plus 5 times 6 to the 0 power. 6 squared is 36, so it's 1 times 36 plus 6 is going to be what? 4 times 6 plus 5 times 1, because 6 to the 0 power would be 1. So I will have 36 plus 24 plus 5. And that's going to give me what? 60 plus 5. That's going to give me 65. So this is now 65 base 10. And our goal is to convert this now. Convert to base 4. So how do we convert to base 4? We do the division algorithm we just went over earlier. So it's 65. I'm sorry. So I'm going to begin to divide by 4. When I divide 65 by 4, it goes there 16 times. 4 times 16 is 64. 65 minus 64 will give me a remainder of 1. I'll put a 1 here. And then I'll continue to divide until my quotient is 0. 4 into 16, that's going to go 4 times. 4 times 4 is 16. 16 minus 16 is 0. So that's my remainder. I'm going to put it over there. I'm going to continue dividing. 4 into 4 is going to go 1 times. 4 times 1 is 4. 4 minus 4 is 0. And then I'm going to divide. 4 going to 1 cannot go, so we say 0. 4 times 0 is 0. 1 minus 0 is 1. And then the result, I have to read it from bottom up. It's going to be 1, 0, 0, 1, base 4. So now we have our result. Again, these problems are very basic. You just have to follow closely the layout, the procedure we follow, and then take some time to go and visit our website and do some practice online and see how really it works. Again, thank you very much. It has been a production of you, the Foundation for Equity and Excellence in Education in Liberia. We are on the web at www.feeliberia.org. You can visit us on the web and have access to more of the work we do. You can also follow us on Twitter, like us on Facebook, and don't forget to subscribe to our YouTube channel. We also appreciate your feedback. Send your comments to feeliberia2015@gmail.com. Also, if you can, please make a little donation to us through by visiting our site. Every contribution you make helps to make us improve our product and provide more content and to expand our services to Liberian students. Thank you.